Hello everyone, welcome to Digital Learning by Professor Praveen Pichar. In this video, we are going to learn basics of series circuit, parallel circuit, formula and example of series and parallel circuit, and some measuring devices. So as there are two types of connection in electrical circuit, the first one is series circuit. What is series circuit? Series circuit is basically electric circuit in which the elements or component or device are arranged in a equal or in a sequence. So here we will consider a simple example here. I have considered here three resistances. First is this R1, second one is this R2, and third one is this R3. All these three resistances are connected in a sequence. That's why this type of connection is called as the series connection. Similarly, I have considered here the two bulb here. You can see that this is the first bulb and this will be the second bulb. Both bulbs are connected in a sequence and this is connected to a supply or battery. So we will conclude that in case of series circuit, the elements or the device are connected in a sequence. Now similarly, the second type of the connection is a parallel circuit. In case of parallel circuit, the circuits are connected in such a way that it will form a row, or we can say that branch of the circuit. We can say that the parallel circuit is the electric circuit that arrange in a row so that it will form a branch in the circuit. So I have considered here an example of three resistances. So this is the first resistance R1, this is the second resistance R2, and this is the second resistance, the third one resistance is R3. All these three resistances are connected in a row. You can see that, and or we can say that the end points are connected to each other and all this combination is given with the supply voltage V. So in case of parallel circuit, the elements are connected in a row. Now I have considered another example here of a bulb. So this is the first bulb and this is the second bulb. Both bulbs are connected in a row, so that we will say that these two bulbs are connected in parallel and it is connected with the supply. So now we will see the basic analysis of series circuit as well as the parallel circuit. Now in case of series circuit, I have considered here two resistances here R1 and R2, and here I have considered the three resistances R1, R2 and R3 here. I have connected with the source supply here of 6-volt battery and this is with the another battery source. So I have to analyze this series circuit. As I have told you that in case of series circuit, the resistance are connected in a sequence. So I have to find out the three expressions here for the electric current, voltage and resistance. So what will be the values of current, voltage and resistance in case of series circuit? So I consider here that the current through this R1 is I1, current through that R2 is I2, and current through that R3 resistance is I3. Now as these are connected in sequence, so the current throughout the circuit will be same. That means the supply current Is is equal to I1 is equal to I2 is equal to I3. So what we conclude that in case of series circuit, the current throughout the circuit is constant or the same. Now what about the voltage here? We have considered here the source voltage, that is the 6 volt in this example. So the source voltage is basically the addition of all the voltages. So what is that? V1, V2 and V3. V1 is the voltage drop across resistance R1. V2 is the voltage drop across resistance R2 and V3 is the voltage drop across resistance R3. So as the current throughout the circuit is same, but the voltages are different. So what is the value of V1? V1 is I1 into R1, V2 is I2 into R2, V3 is I3 into R3. But as current are same, so we conclude that the source voltage is equal to V1 plus V2 plus V3. So in that way, the voltage is different in series circuit, but current is same. Now what about the equivalent resistance? So this Rs is the total resistance, series resistance or equivalent resistance. It is simply the addition of all the resistance connected in the circuit. So here I have connected three resistance R1, R2 and R3. So equivalent resistance is R1 plus R2 plus R3 plus R3. If there are n number of resistance, so it will be go up to plus Rn. So what we conclude in a series circuit is that in case of series circuit, the electric current is constant, the voltages is not constant, or it will be different depending upon the number of branch resistance, and equivalent resistance is simply addition of all the resistance. Now we will see the analysis of parallel circuit. So I have considered here two resistances. First one is R1, another is R2. So I consider here that another devices here, two bulbs are there, they are also connected in parallel. So I assume that here the total current, supply current is I. I have considered here that is IP, that is the total current in a parallel circuit. Now at this point, at this junction, the current is divided into two parts. One will go to R1, another will go to R2. So current flowing through that R1 I will call is I1, and from this I will call as I2. So what happened here? The current is divided into number of branches of the resistance. So if I apply KCL at this point, what I will get? The total current is equal to I1 plus I2 plus I3. If there are n number of resistance, so this will be go up to In. So what we will conclude here is that in case of parallel circuit, the current is divided depending upon the number of branches or number of resistance, right? Now what about the voltage here? If we say the voltage, the total voltage is equal to V1 is equal to V2 is equal to V3. I already told you what is V1 and V2 and V3. So here the voltages are same, because the battery gives supply to all the resistance, means R1, R2 and R3, means it is connected across to each resistance. That's why the voltages are same. So we conclude here is that in case of parallel circuit, the current is different but the voltage is same. Now what about the equivalent resistance? The equivalent resistance is calculated by this formula. It is a reciprocal of 1 upon Rp is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. If there are n number of resistance, so we will be simply here 1 upon Rn. So the equivalent resistance is simply the addition of reciprocal of all the resistance. So this is the basic analysis of series circuit and the parallel circuit. Now we will consider few example here. So first I will consider a series circuit with a resistance. So I have considered here the circuit where three resistance R1, R2 and R3. This is R1, this is R2 and this is R3. All these three resistance are connected in series with the source. So what will be equivalent resistance? Simply by using a series formula, just we have seen that the total resistance is the addition of all the resistance R1 plus R2 plus R3. So R total is come out to be 51. So this is a simple way. So you can see that the three resistance can be replaced with the single resistance whose values is 51. Similarly, I will consider the parallel circuit. So I have considered a parallel circuit. Again, I have considered three resistances R1, R2, R3 whose values are 15, 15, 30, and this combination is connected with the source. And what will be the answer? So I have used a parallel resistance formula. We have seen in the analysis 1 upon R total means the equivalent resistance 1 upon R1 plus 1 upon R2 plus 1 upon R3. So we will find out its reciprocal. So answer is come out to be 6 ohm. So in that way you can see that all these three resistance connected in parallel can be replaced with a single resistance whose value is 6 ohm. Now similarly we will consider the combination of both the circuit, that is series as well as parallel circuit. So I have considered here this R2 and this R3 both are connected in parallel and the combination is connected in series with this R1. So we will have analysis of both the resistance. So I have considered that total resistance is the R1 is series with the combination of R2 and R3. So if we put the values of 15, 30 and 30, we will get the final answer, that will be the 15 ohm. 15 ohm is the actually answer of these two parallel combination, and if we add with the total resistance, the final answer is come out to be 30. So we can see that the complicated circuit we can easily solve out with the help of series and parallel connection if we are aware of the formulas. Now next, what are the measuring devices available in electrical engineering to measure the resistance? So basically the basic meter is called as multimeter. Multimeter is a measuring device that is to measure the resistance, voltage and electric current. So I have a picture of that. So it is a digital meter. So this is a digital multimeter. So with the help of that we can measure voltage, current and resistance, and this is the analog meter also I have shown here. So with the help of the multimeter we can easily measure the resistance here. Now I have shown with the clear diagram of the multimeter here. So this is the DCV. So this is the, we can measure the DC voltage. This is the ACV. So we can easily measure the AC voltage. This is the DCA, means we can easily measure the electric current. So we can measure the DC current as well as the AC current, and it has shown this one is, you can see 220k like that. So you can easily measure the resistance. So if you want to measure the resistance in laboratory, we can use the multimeter. So I have shown in here also. So with the help of the multimeter, we can easily measure the resistance. Thank you very much for watching my video.